Let's say we have this vector. Don't worry about the value of it or the direction of it. It's not a big deal here. Don't worry about the length of it. We'll call it vector A. And this has an angle theta. And I want to find the components of that vector. That vector is going to have two components. It's going to have a component in the x direction, a component in the y direction. And the way you calculate the component in the x direction is you really make a triangle there. And this portion is known as the x component. And this y value is the y component. So when you take that vector and you break it down to x and y component, you're going to replace it with two values. One in the x direction. You're going to have a value in this direction that's known as the x portion of it, or the x component. And you're going to have a value, notice it's going up there, in the y direction. And the question, what are these values? What is that x component equal to? And what is the y component equal to? Well, let's derive these two equations. In case you're wondering why we're covering this topic right after trig. Last class we did right triangle. Now let's talk about the x component. You have a right triangle. You know A and you know theta. You know this value and you know this one. And you want to find the x. So this side is what? Opposite or adjacent? Adjacent, this is what? Hypotenuse. Which trig identity has adjacent hypotenuse? Cosine. The adjacent, which is x, over the hypotenuse, if you want to call this r or c, whatever you want to call it. So when you play with the math, you end up with the x component is equal to the length of this vector, the magnitude of it, times the cosine of theta. Because if you multiply both sides of the equation by r, you end up x equals r cosine theta. And if you want to find the y component, y is the opposite, that's the sine. So the y component is equal to what? R times sine theta. So that's how we find the x and y component. You always want to make sure theta is always measured with respect to the positive x-axis. That's your reference when you measure theta. Let's take an example. Again, use your protractor to prove this stuff really works or not. Let's draw. Again, I'm going to eyeball this one. It's nice to have a graph paper. I forgot to bring some. It's all right. Thank you. The only reason I want the graph paper so you can make sure your x and y axes really make a 90-degree angle. So mine, I'm a little bit off today. My x and y axes don't really make a 90-degree angle. Well, close enough. I can see if you look closely at my line and the 90-degree, there's a little gap.
Can I borrow this one?
Sure. Somebody pick a number between 0 and 90 degrees. So we can go in that direction. What is it? 35? Miles said 35. Somewhere in that direction is the 35. Can't really tell which one of these notches, but somewhere there's the 35. And let's pick a length for that. How many centimeters you want to use? Somebody choose a number. 7. Tom said 7. So the length is 7, the angle is 35. According to my notes, we just finished saying that if I want to find the x component, it should be what? 7 times cosine 35 degrees. So take your calculator, make sure you're in degree mode. And thank goodness I looked on mine because it was in radian. 7 times cosine of 35. And I got 5.7 roughly. And the y component equals what? 7 times sine of 35. $4.0. Let's see if we are right. Let's make a right triangle here. Bring that piece down, 90 degree down, straight down. Now if I take my my ruler there and I lay it horizontally here on this side from here to there, it should give me the 5.7 if we did it right. Here's my ruler now. I'm just a hair off. Notice I got 5.8, looks like it. And if I take it and measure it this way, what should I get? 4 centimeters. So if I take it and measure it this way, I should get 4 centimeters. I got roughly 4.1. Just a hair over 4. Yep, you got 4 on the money? It should be. If we did it right there, the number should match. So that's what you're finding. For example, if you know somebody actually, let's say a plane was going this direction, flew for 7 miles at 35 degree heading and crashed right here. And you want to send people to look for them. Because we're not sure if they're survivors or not. It's cold outside. We're not going to leave them there. And you can't really walk this way. It's too nasty to walk. You can go in this direction, 5.7 miles. Then when you get to that point, go straight up 4 miles. You should find them right there. So that's what I'm going to tell the rescue people. Go 5.7 east, then go 4 miles north. You should be at the crash site, and you can find them. So that's how we find the x and y component. The only problem with that, if you are in the second, third quadrant, we got to be careful there. So let's take a vector and see. I'll show you how you can avoid these problems. I'm going to put the angle in the third quadrant. I got to flip my calculator upside, my protractor upside down. And let's say I'm going to go, I don't know, I'll go 60 degrees down here. 60. That's in that direction. Bless you. And let's measure, let's pick a length for that. What do you want? 10 centimeters? That's 10. And this is 60. Now to find the x component, is going to be what? R times cosine what? Theta. So what's R here? How long is my vector? Is it 10? Times cosine what angle? Try again. Because notice the x value should be negative. So if you use cosine 60, it's not going to work. You always want to measure your angle from here. So what's that angle if you go from here? It's 180 plus the 60, which is what? 240. Because we know the x value should be negative, we know the y value should be negative. If you use 60, your x and y will be the same number, but they'll be positive. So what's 10 cosine 240? That's a negative 5. Negative means you're going to the left instead of to the right. And the y component should be what? R times sine theta. R is 10, sine of 240, negative, I don't know, 8.7 maybe. 10 times sine of 240, negative 8.66. Negative 8.7. That's you. Again, let's see if we did it right. Let's make my triangle here. Let's measure the x value. We know it's to the left, so it's a minus because you're going to the left. How many units? Let's lay that ruler there, see if it's 5. Look at that. 5 on the money. Let's measure the y value. It should be negative because you're below the y-axis. Is that 8.7? Look at that. That's the 8.5, and you pass that by a little bit. 8.7. Below the x-axis, y is negative. To the left of the y, below the x-axis, y is negative. To the left of the y-axis, x is negative. So that's why x is negative to the left, y is negative. So you tell them go from here, go 5 units to the left and 8.7 units down. You should find that spot there. So you always want to measure your angle reference. This is your reference. When you're doing the calculation, always use that number as reference to get the plus minus, the correct one. Otherwise, your numbers will be a little bit off there. You will not get the correct plus minus. So if you know r and theta, you can find the x and y component. What about if you know the component? Can you find r and theta? So let's look at that. If you know the x and y components, the question, can you find r and theta, the angle? If I said to you the x component equals 6, the y component equals 8. Find r and theta. Well, let's see. Maybe I'll use a scale 1 to 1. One to one, so I'm going 6 units in the x direction. Let's go 6 centimeters. I'll use 1 for 1 here. That's right here to 6. That's the 6, the x component. When you get to that point, this one says go 8 units in the y direction. Go up 8 units. Straight up. Can you tell me now what is r and theta? This is r and this is theta. Well, r should be what? Let's measure the length of that. The length of that, I'm getting roughly what? Just a hair under 10. I'm getting like a 9.9. And the angle, I'm getting, let's see, what angle when you measure that angle for the blue line? What are we getting here? Is that 53, 54? What do you think? I'd say 54. I might be a little bit off there. Well, I don't want to graph these every time somebody gives me x and y component, trying to read them. I want to do them using math. So how do we find them? How do we find r and theta without having to graph it? Look at your picture. What do you see there? Right triangle. What do you know about right triangle? Yep, Pythagorean theorem. R squared equals what? X squared plus y squared. So really r is the square root of x squared plus y squared. In this case, x is 6 squared, that's 36. Y is 8 squared, that's 64. And that should give me a value of 10. I got 9.9. You probably got a 10 there if you did it right. And how do we figure theta? Notice what's given to us is the adjacent and the hypotenuse. Correction, the adjacent and what? The opposite. Not hypotenuse. We know this. We calculated the hypotenuse. I don't want to use that, just in case I made a mistake in it. So I'm going to use these numbers. That's adjacent, and that's the opposite. So what trigonometry has adjacent opposite? Tangent. So tangent theta equals the opposite, which is 8, or the y value. Let's just put them as y and x for now, over the adjacent, which is x. Which means theta, if I'm looking for theta, I got to take the inverse tangent. So theta is going to be the inverse tangent here of 8 over 6. So second tangent, 8 divided by 6, close that. It's 53 degrees. So to find r and theta is really 10 angle 53. I wasn't that far from it. I said 9.9 angle 54. I'm off by 1 degree. I'm off by 1/10 when I did it with my ruler there. So if you know x and y, you can find r by using this one. And you can find theta by using this one. Here's one little minor problem. Your calculator will screw up if you're in the second or third quadrant. If you're in the second quadrant, one of them is negative, but it doesn't know which one, it always gives you an answer in the fourth quadrant. And if you're in the third quadrant, x is negative and y is negative. When you divide negative by negative, what do you get? Positive. It thinks the answer in the first quadrant. So it gives you an answer in the first quadrant. So if you are in second or third quadrant, make sure you add 180 degrees, 180, not 18, if you are in second or third quadrant. Well, how do you know you're in the second or third quadrant? The x value is always negative for second and third quadrant. So if the x component is negative, you're going to be second or third quadrant. So just add 180 to your answer. Negative number. So if the x component, I don't care about y. If the x component is negative, always add 180 to your answer for that angle. Yes?
So why do we use tangent instead of like sine?
Because you don't know what the hypotenuse is. You were given the adjacent and the opposite. You could use it once you calculate r. But I usually don't want to use any value I calculated just in case I make a mistake. So why take a chance? Because if this is wrong now, guess what? If I use the sine cosine, since this is wrong, I'm going to be wrong. But if I make a mistake with this and I use the correct values here, there's a good chance I'll get the right answer there. So to summarize this section, I'll summarize it for you. And that'll be the end of this section. I'll make it in big writing so you, bless you. If you are given r and theta. And you want to find the x and y. Here we go. The x component is always equal to r times cosine theta, and the y component, it's always equal what? R times sine theta. Here we go. Make sure that theta is measured with respect to the positive x-axis. If you are given x and y component to find r, it's always going to be the square root of the x component squared and the y component squared. And theta is going to be the inverse tangent of y over x. Right here again, make sure to add 180 degrees if theta is in the second or third quadrant. How do you know you're in the second or third quadrant? The x component will be negative. So if the x component is negative, always add 180 degrees to your answer for theta. So that's the summary of this section.